All right, so in the previous lesson, we managed to get our calculators to start accumulating numbers, and we're able to use any of these buttons, say plus, minus, times, or divide, to start accumulating a different number. So we're already on our way to building our calculator. Now, in this lesson, I just want to show you there's one thing that we could do to make our code a little bit more secure and less prone to unexpected errors. And that is by making this variable, which we're using to track whether if the user is finished typing number, to a private variable. And in order to make it private, we just add the keyword private in front of the keyword var, and this variable is now private to its current scope. So what that means is that if you look inside the parent block, so this variable is only accessible between these two curly braces. And if you try to access it from anywhere else, so say, for example, if I was to go and create a new file, let's create a new Swift file and let's just call it test, because we're going to delete it very soon. And inside test, I'm going to create a new class. And this class is going to be called test, and we're not going to inherit from a superclass. We'll delete that. And inside test, I'm going to create a new object of our view controller. And this is going to be equal to view controller. So in the init of this class, I'm going to tap into that brand new view controller with a lowercase v, and I'm going to try and tap into its is finished. So you can see it doesn't exist, right? It's not letting me get into that private var at all. But let's see if I delete that keyword private and make sure that you save this view controller file while your cursor is inside the file. And now if I head over to my test.swift, then I can say view controller dot is finished typing number, and you can see it's now accessible. And again, if I just go ahead and add this private over here and hit save again, then over here you'll see that this will soon turn into black. Then if I hit Command B to force it to build, then you can see that it says is finished typing number is inaccessible due to private protection level. So what exactly is this whole private protection level anyways? So Swift has something called access levels. And a good analogy for access levels is kind of like the clearance level that people working in the government, for example, have. I don't know about you, but I watch a lot of shows that involve the CIA or the FBI or, of course, Jack Bauer. And what you hear very often is something like, you don't have clearance to view this file, right? And there are certain things that are top secret and only a select number of people can have access to it and see it. So, common things are there aliens? Did we actually land on the moon? And all of these things. But this is exactly what Swift access levels do. Now, while most programming languages have different access levels, they're slightly different from language to language. Now, Swift 4.2 and above have 5 different access levels, or 5 different tiers of clearance, if you will. And the first tier is private. This is, as the name suggests, very, very limiting in scope, and it means that when you create a property or a method inside a block of code, then that property or method is only accessible in between the curly braces of that block of code. Now, the next least restrictive is something called file private. And as it suggests, it means that your property or your method is only accessible inside the file that it was declared. So this will be your viewcontroller.swift or your test.swift, and you can't access a property or a method from a different file. Now, the third one is what's called internal. And this means that your property or methods are accessible anywhere inside your current app module. So this is also the default level of access that all properties and methods are given. And it means that if you don't add the keyword private or file private in front of your var or your let, then this is exactly what it will be. It will be internal access. And it kind of makes sense, right? By default, Xcode lets all the files in the app access all of the other properties and methods in the app. Now, the next level is public, and this means that access is granted to other modules. Now, when we were working with CocoaPods, you saw that we had a pod module and we also had our app module. And this is exactly what the public access level was created for. It's when you're creating frameworks or APIs or SDKs or libraries, basically a bunch of code which you want other modules to be able to tap into and use. Now, the final one and the least restrictive access level is called open. And this is basically like public plus, right? This is everything that you get in the public access level, namely the properties and methods and everything can be accessed by other modules, but also it allows your classes and functions to be subclassed and overridden. So it basically means that anybody can do anything they want when you label something as open. Now, for your standard app development, you will only use 1 to 3. That's the only ones that we concern ourselves with. But for developers who are working on frameworks, library, SDK development, then they will be looking into using 4 and 5. And this is because their module that they're working on, their library or their framework, is going to need to be exposed to other developers. And the only difference between these last two levels is that public doesn't allow the class or the function to be subclassed or overridden, while open basically lets you do whatever it is that you want. So if you take a look at, for example, the Klima project that we built previously, and you look inside the pods module, so everything that has a blue icon is its own module. And remember, we mentioned that the internal, or rather the default level of access everything gets is module wide, right? So that means everything that you declare within Klima will have access to everything else that is inside Klima. Now, in this case, when we're using pods, we actually have two modules now, right? Pods and Klima. And inside the pods, one of the ones that we've incorporated is Alamofire. And if you look inside the Alamofire code, you can see that there's public all over the place, literally all of the methods that are needed when somebody incorporates the Alamofire pod is going to be marked with public to allow this module to tap into this file and these methods. So coming back to our code, the best practice when you're thinking about access levels is to, by default, just give everything a private keyword. Whenever you write a var or a let or a func, so any of your own properties and methods, just write a private in front of it as well. Now, in a lot of cases, it can't be private because you need to use it somewhere else, outside its current scope. But if you start off with private and you level up to file private or to internal, then that means that you are starting out by being extremely restrictive and extremely safe, and you only expose your properties and your methods a little bit more as and when necessary. So what are the advantages of marking something private anyways? Well, it means that you can't accidentally modify something that is not meant to be modified by a different class or from a different place. So inside test that I created earlier on, let's say that I try to change isTypingNumber to true. So now, if we didn't have this variable marked as private, then this other class test could legitimately modify this property isFinishedTypingNumber to true when it's initialized. And this is definitely not what you want, right? We don't want this tracker to be modified by anybody else because nobody has any business in messing around with the state of this Boolean. it should only be accessed by this current class, and only when the typing is indeed done. So for example, when the calc button is pressed or when the calculator is initialized from scratch. So this should be something that is completely private to this class. And so we should, in fact, mark it with a private to prevent accidental modification by other classes. Now, this can happen accidentally. So say you forget that, what was the purpose of is finished typing number, or in another case, if you're working and you're collaborating with other developers, they might have used this name for something else in a different class and they accidentally modified the one in the view controller class. All of this can happen accidentally. So to prevent that and to make your code safer, try to use access levels by starting out with private for all of your vars and lets and methods, and leveling it up only when it's necessary. Alright, so let's go ahead and delete that test file because we won't need it from here onwards. And I've got a challenge for you just so that you can play around with the code so that you can better understand these ideas that we've talked about in this lesson on Swift access levels. So this is a Mac command line tool that I've created, and it's got simply two files. One is called a file, and inside a file, there is a class, and there is also another class in the same file. You can see what I'm getting at. Now, there's also another file which has a class called another class in another file. And inside a file, I've created a private var, file private var, and a normal var, which remember is going to default to internal. Now, just for comparison, I've also created a local variable because remember, when we're adding access levels, we're only able to add it to our class properties, which are in fact global variables. They're not the same as local variables. So I want you to go through these steps 1 through to 10 and try to complete all of the instructions. Now, in order to do this, you're going to need to initialize some objects, you're going to need to call some methods, but essentially, through completing these 10 steps, I want you to be able to see for yourself just what these access levels do. And the ones that we're going to be exploring are the ones that you're actually going to use as an app developer. So from private, file private, internal, and local. And once you've completed this exercise, you should have dissected the differences between all of these and understand exactly how they work and what their scopes are. So let's go through step 1 together just so I can show you how to do this. So step 1, the instruction is try to print a local variable here. So you can see I've already created a local variable as a var inside method A, inside a class. So in order to print it here, all I have to do is say print. Now in my print statement that's going to get sent to the bottom of my debug console, I want to know where it came from. So in addition to simply printing my a local variable, I also want to say a local variable printed from method A in a class. So now here's my print statement and I have to make it work now. I have to make it actually run. So if you remember from previous lessons when we dug into intermediate Swift, we can use the Mac command line tool by calling commands inside this main.swift. So in order for this method A to be carried out, I have to initialize a new object from the class A class and then call the method A on that object. So I can do that by saying let a class equals a class, and we'll initialize a new object from that. And then I'm going to tap into that lowercase a class object that I just created, and I'm going to call the method A on it. So now what should happen is once I run this command line tool, it should go in and try to create a new object from this class, and then it will run all the code inside method A, which should hopefully print our a local variable to the debug console. So let's give it a go. All right, great. So it says local variable printed from method A in a class. Program ended with exit code. So that's the end of our execution. And that is exactly what we wanted to happen. So step 1 succeeds. So next to it, we'll mark that it is possible to print a local variable within method A within a class. And now I'm going to go ahead and either delete or just comment it out so that you take it out of the functioning code. Because if we get loads of these print statements, as you can see, we've got steps 1 through to 10. It'll get very confusing in the debug console. Now, this is completely up to you, whichever way you find easier, but I find through testing that students get a bit confused when there's like 10 print statements. So just go ahead and comment this out if that helps you. Now, in the next lesson, there is a quiz where we'll test to see whether if you've actually managed to make all of these work, because some of these steps are indeed possible, and some of the other ones, because of the restrictions in access levels, are not possible. So the idea here is that before you start executing the code and running it to prove to yourself whether if it's possible or not, I want you to go through this step by step and try to predict whether if they should be possible or not. Because as always, I think the best way to learn programming especially is to predict what should happen and then run the code and see what actually happens, and that difference between your prediction and the actual reality, narrowing that gap and trying to make it so that there is no difference between your prediction and reality is how you really level up as a programmer. So step 1 of completing this challenge is go through these steps 1 through to 10 and see what they're trying to ask you to do, and then using your knowledge of Swift access levels, try to predict whether if they are possible or not in the locations that they have been specified in. And then the next step is to go through steps 1 through to 10 and try to carry out the instructions to print whatever it is that you need to print at the location where you're asked to print it. And then you might need to initialize objects or call methods in order to make it show up in the debug console. So as we're in the advanced Swift section, I'm not going to give away any more solutions, and it's time for you to mess around with the code and really learn through doing. So pause the video now and download this file from the course resources list and go ahead and try to complete it. Once you're done, head over to the next lesson and complete the quiz so that you can check to see if you've got all the answers right. All right, so have fun. Go ahead and do that now.